going to explain in terms of scalability, performance optimization. Okay, I'm going to explain in terms of that. Okay, topologies, network topologies. Okay, for now, what is network topology? Okay, what is network topology? What is the meaning of the word topology? Arrangement. Topology, if you take out the dictionary, you'll see topology is nothing but arrangement. So, network topology, nothing but arrangement of network. Here, not arrangement of network, arrangement of devices in the network. Okay. Suppose we have 1, 2, 3, 4. We have 4 devices. 1, 2, 3, 4. Now, how these devices are arranged? Here, arrangement of devices, what do you think? One is there, one is here. No. How are they connected with each other? How are the links between them connected with each other? Those all define the topology. Nothing but the arrangement of devices in the network with respect to the links or the connecting mediums. Okay, that is the network topology. Got my definition? Got the definition? Now, example. Now tell me how are these connected? These are connected in ring manner. How? Swing, right? Ring manner. Let's suppose these are connected like this. Swing. How are these connected? In this case, if you see in this case carefully, each device is connected to each and every other device. Every other device. This is connected to this also this. Okay, you can see. So this is called as mesh topology. Mesh topology. We learned about ring topology. We saw mesh topology. We will see one. We will see one. Now we have a central device here called as hub. Okay. Device 1, device 2, device 3. Okay. This is also known as star topology. It's like star, bro. Let's suppose these two devices are connected upwards. It will look like star. Okay. Star topology. We have one more. A straight cable, Ethernet cable runs here with terminators at the end. Okay. We have devices connected here. A, B, C, D, E. These are nothing but known as drop links. Okay, this is called bus topology. Okay, now we have seen the formats of frame formats, arrangement formats of all of this. Let's go one by one. Okay, let's go one by one. First form of topology, simplest form of topology, point to point. P2P, point-to-point topology. Very simple. We have device A, we have device B. Connect. Okay, connect. This is nothing but point-to-point topology. This is a link. Let's suppose Ethernet cable in your office. You are okay. Or computer labs. You guys go to computer labs, libraries. Okay, digital libraries. There are two computers connected by some Ethernet cable between them to transfer the data. Okay. This is nothing but point-to-point topology. The arrangement of devices in such a way that there is only one link between there is only one present link between any two devices. Okay, that is nothing but point-to-point topology. Now, what people said, okay, why you have connected two devices? What if there are three devices present? What if there are three devices? Okay, 1, 2, 3. Okay, third device C. Okay. Now people start connecting all this. Okay. Now what is the D device? This. See, as soon as the number of devices rises, you can see the number of links also increasing, and you can also see that number of wires are also increasing. Okay. These are all headache. Okay. Now what one person said, bro? I will come with something called as, as the number of devices are increasing, we need to maintain each and every link between each and every device, which is very expensive. So I have come with a pattern with something called as bus topology. Bus topology. Here what these people are saying, I have a common bus central cable running. I have one central cable running to which you can connect any number of devices. You can connect A, you can connect B, you can connect C, you can connect D, you can D. So the advantage here is connection of devices to the network is very easy. Very easy. And it was cheap. These were used in early Ethernets, 1980s, 1970s Ethernet. Okay. Very older Ethernets. So in this bus topology, you have something called as terminators at the end. Terminators. So what are these? These are absorbers of data. Suppose a device sends the data, it will go here, everywhere. If it goes here, it will just absorb it. It will not reflect it again. If it reflects again, it will be a problem because some device has received the data. This device will again receive the data. If these are reflectors, so they have terminators which absorbs the data and just dumps it out. Okay. It just throws the data. Getting my point? Now he said I have central concentrator. This cable is known as concentrator cable. Concentrator cable is nothing but I am the main one sitting here. If I am not present, whole system is damar. That's a disadvantage. That's a disadvantage. If this cable fails, if this cable has a cut in between, gone. Entire network swing, gone. Okay. What you can call single point of failure. Single point of failure. What is the point of failure? Central concentrator. Central cable, okay, that is something but single point of failure. Okay, and what is the second disadvantage? Let's take a scenario. We have device A, we have device C. Now, A sends the data. A sends the data to E. A wants to send the data to E. It has created a frame with source address, destination address, MAC address. Okay, source and destination address. It sends out the frame. Now C wants to send the data to B. C wants to send the data to D. Now this also creates a frame. Source address is nothing but C address. Destination address is D address. It also sends the data to. Now we have single cable here. We have only one cable. Now digital signal is traveling here. From here digital signal is traveling. Now you can see these two signals crash. These two signals have crashed here. This will result in loss of data. Okay, loss of data. Nothing but collision of signals can occur. Collision of data can occur. Okay, biggest disadvantage in bus topology. Then what did bus topology do? So what these people did? These people came up with something called as CSMA CD. Carrier sense multiple access collision detection. A very complex word, but it is very beautiful. Carrier sense multiple access collision detection. Okay, it's very good word. It's very good product. So this is a technology which was used in bus topology because most of them were blaming them. Collision hota hai. Why bus topology when there is a lot of collision? Okay. Now they invented this technology saying, first of all, what is carrier sense? I'll explain it in very simple terms. You will not get this anywhere. Carrier sense. Now, carrier sense. I explained about NIC, network interface card. That is responsible for taking the bits and converting them into signals and sending it out to Ethernet. Now, every NIC present in device, these have the ability to sense this line, to sense this cable. Now, NIC know what an empty cable looks like. Okay? So if there is any data present here, NIC can sense it, that there is some data. Okay? That there is some data. Now what NIC will do? First it will sense the carrier. Sense the carrier is nothing but check if there is already any signal propagating in the cable. Okay? That is known as carrier sense. Carrier sense, sensing the cable. Second thing, multiple access. Multiple access is nothing but each and every device present here can access the cable. Each and every device has NIC. Okay. Each and every device has NIC. Each and every device has the right to sense the cable. Okay. Collision detection. collision detection. Now, what will, in basic condition, basic scenario, what will happen? Suppose NIC detects that no signal is getting propagated in the cable. Now, what NIC will do? It will tell the system, produce the data, take the data, push it onto the network. Now, E device, now when the data is traveling here from the A to E, sees NIC will sense the data. Sees NIC will sense the data, it will check, oh, some data is there. I am not going to send it. Okay, it will wait for some moment of time. Okay, once the signals, the cable becomes free, it will sense again. Now it will say, okay, it is empty, send it. It is empty, send it. Got to point. That is nothing but this protocol. Very important protocol, bro. Very important protocol. Carrier sense multiple access collision detection. Okay, note it down. Carrier sensing the cable multiple access. Each and every NIC of the device has the right to access the cable. Collision detection. Okay, this part I haven't explained. Collision detection. Okay. Now, suppose let's take a scenario. This is very rare, but happened. That's the reason ring topology came. I'll explain what happened. Okay, we have A device, we have C device. A's NIC sensed the cable. Okay, it saw it was empty. C's device sensed the cable at the same time. At t is equal to 1 second, 1.0001 second, A sensed the signal. A sensed the cable. There was no signal. At the same time, 1.001 second, C's NIC sensed the cable. Why? Because it was waiting to send data. Now, these devices sense the cable at the same time. Now, what will happen? These both will send the data at the same time. A sent the data, C also sent the data. Collision, gone. Still, even though having a very good protocol, they still lack in 0.00001%. That collision will happen. That is the collision detection. Now, if collision happened, the NIC will sense the cable. They say, oh, collision happened. Now, this will send a special frame to all the devices. Okay? Any NIC detection collision, it will send a special frame to all the devices. Bro, collision has happened. Please wait for a random amount of time and resend the data. Okay? Suppose A's NIC detected collision. Okay? It will always give a backup of data. It will always give a backup of data before sending it. Now what it will do? It will take the backup, wait for 2 seconds. Now at the same time, C which also detected the collision. Okay, this will take the backup of C's data and will wait for random amount. Suppose this wait for 4 seconds, this waits for 2 seconds. Both will send successful transaction. That is nothing but collision detection. Okay. Got my point? Understood this? CSMA-CD. Okay? We have one more thing called as CSMA-CA. This we'll learn later. This collision detection, that is collision avoidance. Okay? We'll learn that later. For now, this was very necessary because I am explaining bus topology. Okay? Now, we got one more topology. Okay? That was its competitor called as ring topology. Now, who developed this ring topology? You will get surprised. IBM. IBM is a company which developed ring topology. Okay, this was in early Ethernets. Even this. 1990s kind of ring topology. Now, what ring topology does? How it beats this? It is beating this in 2 ways. First thing, collision. Okay. Hey, what was the 2 results I said you? If central thing fails or fails. Okay, how it is building this in that way? Let me explain it. You understood point to point, you understood you understood bus topology, now you are going to understand ring topology. Here devices are arrayed in form of ring. I showed you a few minutes back. Okay, this is nothing but ring topology. Now, how it's beating bus topology? First of all, the main case in which this ring topology is beating bus topology is collision. bus topology, still there's a 0.001% of collision chance. This case, never a collision. That is what IBM developed. How? Let me explain. These ring topology guys, ring topology definition, you can note down the definition. The arrangements of devices in such a way that they form a ring. Each device is connected to two other devices. Okay, that's the reason ring topology, ring fashion. That is the definition. What was the protocol or technology they were using such that they were not at all getting a collision? Token ring protocol, token ring technology. So what is token ring here? Token ring topology. So in ring topology, what was happening is through some external supply of power, some external supply of voltage, they had one frame, one special frame which is on a token, which kept circulating here, which kept on circulating here. Okay, that one special frame. Okay, that kept on circulating between each and every device through these rings only. It was going through these rings only. Okay, now what's the specialty? The rule of ring topology, token ring protocol was only device which holds the token can send the data in the network, or else they cannot send at any cost. It's like ID card, bro. If you don't have ID card, you can't go to college. You can't go to college, just get lost. Okay, only if you have ID card, you can just go inside, you can just send the data. Okay, that's the formula of that's the methodology of token ring. Okay, it says now suppose A, B, C, D. Suppose A wants to send the data. The token is getting circulated here, right? Now what A will say, I want to send the data. First, I must look for the token. Only if I get a token, I'll send. Now A wants to send the data to C. Okay, token is circulating. A picks up the token, and sends the data. Now, this will go here, it will get received here. In the meantime, if B wants to send the data, it will first check the token. It will say the token is not there. I don't have the token, I can't send, I will be quiet till I get the token. Okay. Now, once this data has been sent here, the token is released from A. It will again start circulating. Okay. Now, this time B will pick up. And send the data to D or C, any of the devices. Now, even releasing the token is of two types. Once A sends the data to C, okay, once the data has been received to C, now token has been released. This is one form. Another form of releasing the token is, suppose A sends A picks the token, A will send the data. Now it will release the token only when it receives the acknowledgement back. Okay, it wants the confirmation that yes, my data has been received at the receiver side. Only then it will release the token. Okay, release the token when ACK is received. Got my point? Two forms of application. Now, it still had disadvantages. Connecting new device to a network involved reorg of entire network. Suppose, example, you friends are circled together. Okay, someone comes in between and how much irritation you get, bro? How much irritation? You and your friend have to remove your hand. Again, that guy has to connect his hand to your hand. Another guy has to connect his hand with the new person's hand. Like, if a new device wants to enter here, this link must be destroyed. This link must be here. This link must be here. Any addition of new device requires reorg. Okay, it still has disadvantage. And understood? Okay. One more disadvantage. What if C device damar? What is C gone? C is not at all there in this universe. C just said, I am shutting down myself. Now the link will come in here. C is not there. The link will not go here. Ring topology is nothing but broke down, right? The connectivity is broken down. Even this has single point of failure, bro. If one device gets lost, the entire network is broken down. Ring means what? Everything must be connected. Even if one device got disconnect, each and every device will get disconnected. That's it. As I said, in ring topology, addition of new devices was difficult. Addition of new devices was difficult in ring. That was overcome by star. That was overcome by star. How? They have something called as hub. Hub here. Okay? We have device A connected. We have device B connected. We have device C connected. We have device D connected. Okay? Now, suppose we want to add a new device called as E. What E will do? Just single link, connect, finish, khatam, connected, successful, binding over. Not like ring. First break the existing link, then get the device, then connect these two links. No. Single link, connected, over. Right? Got my point? Addition of new devices is easier here. In star topology. Okay, sorry. In star topology, there are two types. One is hub topology. One is switch topology. Let me tell you why. Actually, in college, you will only learn hub topology. You will not learn switch topology. Because these are arrived recently. Okay? Hub topology. Okay? This is nothing but hub topology. Now, as I explained to you back then, what is hub? Hub is a dumb device. Hub is a completely dumb device which doesn't know where to send the data. If A is sending the data, the hub will blindly send the data to all the devices. What is disadvantage? You know the disadvantage of hub? You can write it here that it doesn't know where to send the data. It will send data to everywhere. It will send data to hub topology. It will send data to everywhere. Okay. That is the reason. Of course, it has beaten the disadvantage of adding a new device to the network. Of course, it has beaten, but still it lacks somewhere. That is the reason switch topology came. It says, remove this hub, me switch will sit here. Me as a switch will sit here. Now, what switch does? I told you, hub is a physical layer device, but I told switch is a data link layer device. Okay, now what are these layers? Don't get worried about this. These are OSI model layers. We have 7 layers in OSI model. Okay, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Don't worry, we will learn all of those. Okay, why I am calling it as physical layer? Physical is nothing but dealing with physical connection. I don't have any respect to data. Okay, whatever comes to me, I will just blindly send it to the cables. I don't know what is there in data. Okay, I don't even know what is present inside the data. If data comes to me, I'll send it. Okay. Now, why is switch called as data link layer device? Because it has access to data. It has access to data. How? Each and every device is connected to switch via some kind of port. Even in hub we have ports, but it does multi-port forwarding, multi-port repeater. Now, as we know, switch is a multi-port bridge. I told you, switch will send the data only to the destination MAC address which is present in the frame of sender. Suppose, Siddharth, hear it properly. We have a device. It forms the frame. We have data here. Okay. We have sender's MAC address. We have receiver's MAC address. Now this data, this frame goes to switch. Switch has maintained some table. Switch has maintained some switching table. How? Whatever device connects to switch, right? It allocates ports 1000, 1001, 1002. Okay? Device A, device B, device C. Suppose A device wants to send data to device C. It will store the MAC address of device A. Whenever the device gets connected to switch, the first thing it does is collects its MAC address. Now suppose MAC address of this is 001B, 2C, 3D, example. Like this we have MAC addresses, okay. In this form we have MAC addresses. A sends the data, A sends this complete frame, complete this frame, switch will pick it up. Now it will see, it will get the access of data. That's the reason it is data link layer device. Data link layer devices have access to data. Okay. Now it will pick up the MAC address of receiver. MAC address of receiver, suppose it's matching to C. Now it will send C to 1002 port, 1002, where is C? Send this data to here. That's it. That's now there is no meaning of collision here. There is no meaning of collision. Why? Each and every device has separate links, bro. Because if A sends the data, it will send the data only to C. It will not send. Each and every link has separate collision domain. All devices have separate collision domain here. What is collision domain? Where there are possibility of collisions. Okay. Separate collision domain means we are separate. Our area is separate. You guys play cricket there. We guys will play on this pitch. You guys play on that pitch. Okay. Don't come to our pitch. It's like that. This pitch is different. This pitch is different. This pitch is different. This pitch is different. It's like separate pitches for playing the cricket. Okay. There is nothing but switch topology. Now, even you know about switch. Okay, bidirectional data transfer. Both devices can send and transmit at the same time. Now, some people are very greedy. Okay, what they said? Okay, you have switch with yourself, but I want super fast data. I don't want the delay of looking up into tables and all. Okay, I am rich, but I want super fast data. I can throw any amount of money. Then into the world came something known as mesh topology. I'll tell you why this is being widely used even today also. Mesh topology. I want super fast data transfer, and one more thing, I don't want collision. I don't want to keep a concept of collision at all. I don't want to get lost. Okay, we have device A here, we have device B, we have device C, we have device D. Swing. The type of topology in which each device is connected to all other devices in the network. Each and every device is connected to all other devices in the network. That is mesh topology. What's the biggest disadvantage? Costly, bro. Hella costly. Suppose there are 100 devices, okay? Then 100 devices must be connected to each other. Device 1 should be connected to other 99 devices. Device 2 must be connected to other 99 devices. Headache. Very costly, bro. Very costly. Okay. But what is the advantage? Super fast transfer of data. Super fast. A to C. It's not like green. Go like this. It's not like star topology. Go to hub will then search or hub will forward to all whoever wants to consume it. Switch will then check the routing table. It's not like that. A to C, direct link. A to D, direct link. C to B, direct link. Direct within second. Okay. Got my point? That is mesh topology. Biggest advantage is speed. Biggest disadvantage. Expensive. Hell lot of expensive. Okay. Why? These many cables and links. Even though being expensive, why this topology is being widely used even today? Let me explain. Where it is majorly used today? Military organizations. So military organizations, they have very sensitive information. They don't believe any networking device. They just know I am connected to other computer. I should be connected separately. Okay. They have very sensitive information. Okay. They not send data to other network. That is thing, and they want very fast transfer of data. Suppose they have to take an instant decision. If Pakistan attacks India, okay. They need to prepare a plan and need to instantly send the plan to other devices. So what they'll do? They'll send to hub, switch, or just they'll broadcast. No, they can't do that. One frame, broadcast to all. That's it. That is the reason mesh topology is being used in military organization today. Almost all military organizations use this because they want fastest means of transport, fastest means of data transfer. Okay, that is the thing about mesh topology. What are technologies used? DHCP. Dynamic host configuration protocol. Bro, for now, you can understand it as a protocol which assigns IP addresses to devices. That's it. This protocol is responsible for assigning IP addresses to all the devices. Okay, that's it. That is nothing but host parent configuration protocol. Understood about mesh topology? Understood completely. Finish this and just let's. Okay, we have something called as tree topology. Tree topology. Now, why did it come here? Why this topology came? Okay. First of all, let me show the arrangement. Okay. We have hub sitting here. We have secondary hub sitting here. Secondary hub. Now these are the devices. If you see, these devices are arranged in the form of tree. It's like tree, roots of a tree. That's the reason. If you see reverse, it will be a tree. If you see, these are roots of a tree. Okay, that's the reason it's known as tree topology. So nothing but this topology overcomes failure between devices. Okay, loss of connectivity. How? We have one more called as hybrid topology. Hybrid topology. So hybrid topology is nothing, bro. Hybrid topology is the topology which combines all other topologies. Suppose you are looking at the metropolitan area network. From the city perspective network, if you see, few offices are connected using ring topology. Okay, few offices are connected using star topology. Okay. Now here we have bus, central bus, and here we have mesh topology. 1, 2, 3, 4, 5, 6. Okay, these all have links to here. One more tree topology I drawn just now. 1, 2, 3. 1, 2, 3. 1, 2, 3. Bro, this is nothing but hybrid topology. Combination of all the topologies is nothing but hybrid topology. Simple. That's it. That's it about topologies.